For decades, the electrical grid operated on a simple, predictable promise. Central power plants generated electricity, massive pylons delivered it, and property owners paid a steady, reliable utility bill. But that bargain has broken. As demand outpaces our aging infrastructure, the system has effectively been priced for pain. Energy has shifted from a boring, fixed operational cost into an unpredictable financial liability, driven by sudden, massive spikes in peak pricing. This chart shows exactly how that liability works in practice. The flat top line is subscribed capacity, the maximum amount of power a property is legally allowed to draw. Notice the huge gap between that ceiling and the jagged red line of actual usage. Property owners are forced to pay massive premiums just to have that peak access available, even if they rarely touch it. Living in that gap, the uncertainty band, exposes owners to spot market prices that swing wildly, sometimes by 74% month over month. Because the system is built for the absolute worst-case peak, up to 40% of the grid capacity you pay for sits wasted on normal days. You are bleeding capital to subsidize a centralized system, penalized for massive structural inefficiencies that are entirely out of your control. Surging costs are difficult enough to manage, but an entirely different kind of pressure is rising fast: unavoidable, strict government compliance requirements. The European Union's NIS2 directive mandates specific cybersecurity protocols for critical infrastructure. For major property owners, this means your energy systems can no longer be exposed, unmonitored endpoints. You are legally required to deploy secure, sovereign digital energy networks. Concurrently, Sweden's civil defense strategy requires municipalities and large real estate operators to establish trygghetspunkter, local safety points that can maintain essential services during a crisis, entirely independent of the national grid. The message from regulators is clear. Buying your way out of trouble with more centralized grid capacity is a dead end. Surviving this squeeze requires severing your total reliance on the grid. The solution to this problem is already sitting on your property, hidden inside your private, low-voltage electrical network. Look at a typical daytime office fleet. Those parked electric vehicles are massive, mobile battery banks waiting to be utilized. Inside the building, heavy industrial HVAC systems and standard backup generators don't have to act as static drains. They can operate as highly flexible, controllable loads. Combine those with rooftop solar arrays and dedicated physical battery storage, and the math starts to heavily favor the property owner. This architectural drawing illustrates how these dormant pieces connect. Your commercial property, your parking footprint, and your connected vehicles already constitute a functioning virtual power plant. The real asset here is vehicle dwell time, the hours those cars sit plugged in and stationary, available to discharge power into the building exactly when tariffs spike. All of this flexibility flows straight through the electrical room and grid connection you already maintain. You do not need to build a power plant. You already own the megawatt capacity. You simply lack the digital mechanism to coordinate these assets and safely monetize them. This flowchart maps the mechanism that operationalizes that capacity without requiring upfront capital. Grid Unlock introduces a special purpose vehicle, an SPV energy tenant. It acts like a commercial renter that leases your spare grid capacity, absorbing the operational complexity and trading risk. The physical brain making this possible is a local energy coordination node installed directly inside your facility server rack. It operates on a strict rule: local first, grid as fallback. By processing data at the edge, the node continuously balances internal demand, shaves expensive tariff peaks using vehicle batteries, and ensures enough backup power remains to meet civil defense resilience mandates. This business case graphic details the financial outcome. Because the SPV tenant funds the hardware and takes on the market risk, you spend zero capital. You convert chaotic compliance burdens and volatile monthly bills into a flat, predictable 12-month budget with positive yield. If we zoom out from a single building to an entire region, a major systemic risk emerges. Decentralizing energy is highly dangerous if it isn't coordinated. Think of early GPS navigation. When everyone gets the exact same traffic alert and takes the exact same shortcut, you create a massive synchronized traffic jam, the TomTom queue. If millions of disconnected thermostats, car chargers, and heat pumps decide to buy cheap electricity at the exact same millisecond, they will crash the grid. We avoid this by trapping volatility behind the meter. By making decisions locally, the node smooths out the chaotic spikes of a building's internal demand. Only the smoothed remainder flow out to the network, protecting local substations from overload. True systemic stability cannot be achieved by a top-down central control room trying to micromanage millions of devices. It requires intelligent local autonomy, actively preventing collective failures. When large private properties self-balance their energy loads, the macro-level impact is immediate. Massive amounts of heavily congested grid capacity are instantly freed up, creating the headroom required for heavy industry and AI data centers to operate. The exact same kilowatt-hour solves 3 problems: lowering bills for property owners, subsidizing EV fleets, and stabilizing the local grid. The marginal cost is shared, but the value multiplied. Society pays for infrastructure once, but reaps benefits 3 times over. By turning dormant assets into intelligent, local-first energy hubs, property owners secure their own financial future. In doing so, they actively democratize the grid, providing the decentralized stability required for a fully electrified system to function.